Hey everyone. Hopefully this video will be shorter. I appreciate you watching the first one. I also am in a time crunch because I'm in a study hall room right now, but it's about to be Gimel, so I'm gonna have to move in the middle and you'll hear the bell and whatever. You gotta do what you gotta do for algebra. Alright, so we're gonna continue talking about rational functions. We're just gonna do two examples today, but we're introducing a new piece of them. And that is that some rational functions can have very high-level math term here, after learning about asymptotes. Holes. Is that like movie/book holes with the guy who steals the shoes and like the family curse? People know about that anymore? Anyway, holes, which there is a math word, a math term, is a removable discontinuity. Or the plural would be discontinuities. Let's see Josh, David, or Kai try to spell that and win. I'm also mad. Like I was gonna beat Rabbi Ranch and give Mrs. Clocky if they kept going. Phalanx. That's a easy word they gave me. I didn't even get to show off. All right. So you'll get a hole. Don't ever say removable discontinuity again. You have more important things to say. Like Yale beating LSU, which hopefully by this point will have happened, because whatever, you're listening to this way after I film it. Y equals, right, it's just going to be, remember, a rational function, a bunch of different binomials. Multiplied. Right, that should look like something from last time. What we should notice is, what is the deal with this? We have the same factor, the binomial x minus 1, in the numerator and denominator. Remember we said things that make the numerator equal to 0, we expect them to be an intercept, an x-intercept, and things that make the denominator equal to 0, we expect them to be a up-down, north-south, vertical asymptote. So, right, is x equals 1 an x-intercept? That's what the numerator would suggest to us. Or is x equals 1 vertical? And remember, we can't abbreviate asymptote. Is it either of them? Right, they suggest different things to us based on the steps we were doing in the first lesson of this unit. And as all great math answers go, it's neither. So, it's actually what we call a hole. You'll see what that means. It's pretty cool. Here's what's going to happen. We're going to cross things out. And we're going to rewrite the function as y equals x plus 3 x minus 1. Oh no, we got rid of x minus 1. X plus 3 x minus 3 all over x minus 2 x plus 4. Now, even though we crossed it out, it was still in the original function, right? And because of that, you should have seen something like this last year when you were simplifying rationals, what's allowed values or not. Even though, or restrictions you call them, x minus 1 is gone from the denominator, not the demon, the denom. X still can't equal 1. But it's not going to end up being a vertical asymptote. It's going to end up being a hole. So what I want us to do first is actually find, whenever you have a hole, right, which means you crossed out something in the numerator and denominator, you have to find its coordinates first. And what I mean by that is plug in that value of x. So when x equals 1, right, which is what we get from this, y equals, and now we're using the function with it already crossed out. I plugged in x everywhere. I should get 4, -2, -1, 5. 8/5. Let me double check that. 4, -2 makes -8 over 5. All right, great. So what this means is whole at 1, 8/5. So we're actually going to graph that before we do anything. Let me pick a good color. And here, I want to pick something that has like a color it can be paired with. Okay. Here is how we graph a hole. We're going to make it an open circle like we sort of did for those inequalities. So at 1, 8/5, which is like 1.4, we actually are going to have a hole. Maybe I should make that a bit thicker with 2 C's. All right, and you'll see how this comes into play. Remember our other steps, and it's going to get kind of smushed, but hopefully not too bad. Now that we have a hole, first step is vertical asymptotes. I'm really going to run out of space here. Okay. Vertical asymptotes, which is denom equaling 0. We've been doing this one in red, I'm pretty sure. Red dotted lines. And we've been circling the steps, so bear with me here. Go Bears, as they say at WashU. Step 1 is vert asymptote, which occurs when denom equals 0, so x equals 2 or -4 for the 2 binomials in there. So x equaling 2 and at the x value of -4. I'm trying to stay consistent. I think we used, I could just like look at them. I did make the notes yesterday. And as you can see now, I'm not even keeping the time in the screenshot because, right, we know Jamin has some issues understanding AM and PM, so I didn't want to confuse him again. But I already gave myself away of the date by saying that the first round of March Madness hasn't happened yet. Which reminds me of another great joke, but whatever, I'll explain that later. And if I forget, just tell me in class. I have a lot of problems with this. 2 is the x-intercept, which is numerator equals 0, which in this case is x equals -3 or +3 from these 2 binomials. So x equals -3 or, well, that was bad, not on the line. Or, well, why is it being weird? Or +3. Pretty sure for the y we used orange. So for the y-intercept, we're going to plug in x equals 0. You're going to have to take my word for it that gives us 9/8. I just don't have room to write all that. When x would be 0, 3 times -3 is -9 over -8. You'd have 9/8. So 0,9/8 is like 1 1/8, right? It's like, whoa, I know you can do that. It's like over here. All right, 4, we've been saying horizontal asymptotes. just in blue. That's blue, right? Which is when we say x goes close to infinity, right? We're going to have y equals, I'm not going to write this out. I encourage you to look at the notes before from yesterday. It'll be good practice to not freak out upon seeing me do something not all the way through. We plug in infinity to the original function. Infinity plus 3 is like infinity. So is infinity minus 3, right? You're going to end up getting like infinity times infinity over infinity times infinity, which is going to make y equal to 1 for the horizontal asymptote. Before we graph it, something we talked about last time was crossing the horizontal asymptote. I'm going to try to find an even different color to do this. Pink. So where would you cross the horizontal asymptote? When y equals 1, right? The horizontal asymptote occurs at y equals 1. When y equals 1, we get y equals the function, right? The y value is 1. There are a couple different ways to solve this. Here's how I would do it. If I multiply the entire, like both sides of this equation by these two factors in the denominator over here will go away, and the 1 will just become those two things, right? 1 times that would just be x minus 2, x plus 4 equals x plus 2, x minus 3. That is something we learned how to solve, right? What I'm doing is just pulling this denominator up here and multiplying it. If it wasn't a 1, right, if it was like a 3, I would have that 3 in front of these. Now I'm going to FOIL both of these. This, I don't know. I would call it an lift, but whatever. Going to FOIL both of these. X squared plus 2x minus 8 equals x squared minus x minus 6. The x squareds will go away from each side. I'm going to let you guys do this maybe, but I'm running out of space. 2x minus 8 equals negative x minus 6. Well, you know, I'll write it down. I'm not so great at algebra. Add x to each side. 3x minus 8 equals negative 6. Add 8 to each side, divide by 3. X equals 2/3. So our cross will be at the point 1. X is 2/3, right? 2/3, comma 1. So by finding out the y value of this blue horizontal asymptote, plugging that in for y and solving for x, you could get that. Now, potential extra credit question. Think about a scenario in which it could cross twice, and what that would have to mean algebraically. Like what would have to occur in the binomials for that to be possible? Think about that. That's definitely going to be an extra credit question. So 2/3, comma, we got a lot going on over here. 2/3, comma, 1. Just want to make that very visible. All right, now let's do some pick a thing. We're going to start over here. I'm really crunched here. When x is greater than, what is this, 3? The value of the original function is going to be positive. First binomial positives, all positive. It's going to be positive overall. You can check that out. Going to start positive over here. Try to think it out in your head before you draw it, because then it might get pretty messy. Positive, going to go through here. This is a cross because the exponent of this x-intercept of the x minus 3 binomial, there is no exponent. It's not squared. So cross, going towards asymptotes but never touching. All right, here it's going to get a bit funky. We're going to use the same trick from yesterday. This asymptote, red dotted line, going up and down, comes from x minus 2. Now I feel like I did something wrong. Wait. Hold on. X, I don't see how this is going to be. When x equals 0, y definitely equals 9/8. Did I get the whole wrong? Did I get the cross wrong? Sorry everybody if I did make a mistake and didn't catch it. That's unfortunate. No, the whole is at 1,8 I think, right? When x is 1, it's 4 times negative 2 is negative 8 over negative 1 times 5. Negative 5, okay, that should be right. 1,8. Did I just graph it wrong? 1,8 no. 0,9. Y equals negative 8, 9/8. When it's 1, you get, I think I did this right. Also, that when y equals 1, right? Did I FOIL this right? X squared plus 2x minus 8. Unless I copied it down wrong. Oh, this is x plus 3. Gotcha. Alright, I'm going to fix that and regraph the whole. Sorry about that, everyone. I know that made it longer than... Never mind. Could have been otherwise if I had it messed up. Alright, so if you already caught that, great. Maybe you can get a bonus point. But then you all just lie and tell me you caught it. So let me fix that up there and then regraph the whole... regraph the crossing of that asymptote. Okay. I'm just going to FOIL out directly over here. X squared, because I'm lazy, and you already saw it. Plus 2x minus 8 equals x squared minus 9. Foiling the numerator. This is the denominator foiled. 2x minus 8 equals negative 9. Add 8 to each side. X equals 1/2. That... Oh, negative 1/2. Okay, so at negative 1/2, comma 1, we have a whole. Negative 1/2, we have a cross. I also want to stress, like, these 3 points are all definitely on this graph, right? And that's going to work out nicely because we sort of... The more information we have, the more we know how it has to look like. Like, it can tell us if things are wrong. I knew that I had done the whole wrong because it wouldn't have visually worked for it to go through all of those points. Back up here. The binomial that produces this red asymptote is x minus 2. It's not squared, so it's not a reflect to stay on the same side, to stay negative. It's going to jump and go positive. It's going to have to go through this. Look at me hit those 4 points in this beautiful scribble I drew. This is from x minus 3. No, from x plus 3, which is no squared. So it's going back here. Approaching asymptotes but never touching. There's a bell. I may have to move in a second. Let me finish this off. This comes from x plus 4, which is not squared. So it's going to diagonally go and then come back up here. All right. There is going to be another one, friends. So if you'd like, maybe skip a bit so I can find another room to go in, and now listen to everybody move through the halls.
I've already finished.
For those of you who are still listening now and would like some comic relief, I listened to Sicko Mode for the first time today. It was pretty good, I gotta say. I was kind of impressed. Not as bad as I anticipated. All right, still looking for a room. I'm still looking. Next time I'm just gonna pick a room or not start this so close to the end of a period, or pick a room that I know nobody will be in, but it's an elective now, so there should be a lot of open rooms. So let me wait till they all
Watch me get a better grade than all of you on the test.
clear up. Hi Remy. Hey Oliver.
Let's go to talk to you about interesting join the softball team.
No, I'm filming another thing and now you're going to be in it. Remy, say something to your friends.
Let's hope we talk to you about interesting join the softball team.
Why is it still video?
Unfortunately,
Why is
cannot.
it still on?
Well, because I was filming it, but then the room switched. Like this, whatever. You're a star now.
But is this on right now?
Yeah, this is live.
Hi.
Friends, you should all actually listen to this part because it's funny. Guys, not guys. All right, we're back. Really, everybody listen to that. It gets good. This is a good video. Y'all told me to make them funny, so hopefully that makes it funny. All right. Let's do one more example. Yeah. All right. Hopefully I fit a space better. Y equals x plus 2 squared, x plus 1, x minus 3, x minus 2 squared. That's squared, sorry. And this will just be more practice to see what happens with these squareds. So, first step is to realize there is a hole. Right? At x equals -1, because that's the value that would make this 0. When x is -1, y equals -1 plus 2 squared times -1 minus 3, right? I crossed it out for the rest of it. -1 minus 2 squared, -1 plus 4. Which is, wait, also let me rewrite the function over here without that gone. It'll just be easier to, oh my god, that bell is so loud. Easier to think about here. Alright, -1 plus 2, again, if you want to write this down more slowly, whatever. -1 plus 2 would be 1 squared is 1 times -4. -1 minus 2, -3 squared is 9. -1 plus 4 is 3. That's -4 over 27. That doesn't seem like a thing Mr. Walkinshaw would put in an example that I stole. I copied it down right, and I mean it'll work no matter what. Cross off the x plus 1. Next is -1. That whole value becomes 1. That whole value becomes -4. That whole value becomes 9. And becomes 3. Sure. -4 over 27. So the whole is going to be at -1 comma -4 over 27. What color did I do that in? This green thing. So let's graph that again first before we do anything. -4 over 27 is pretty close to 0. Again, if I made a careless error, I just checked it pretty thoroughly. We'll see. -1 comma -4 over 27. Let's call it there. All All right, next steps would be the steps are vertical asymptote, which is when the denominator equals 0, which would be when x equals 2 or negative 4 from those two binomials that are left in there. So x equals 2. Remember, and this will be important later, that 2, this one, this asymptote, comes from a binomial that is squared. What have we been doing next? In green, the x ints, which are when the numerator equals 0, which would be x equals negative 2 or 3. And remember, this one comes from a squared binomial, and that will be important later. Next, we're doing y-intercept, which is when x equals 0, y equals, first thing would end up being 0 plus 2, 2 squared is 4, negative 3 over square negative 2 would be 4, so negative 3/4, so 0 comma negative 3/4. We've been doing now just blue for the horizontal asymptote. Same thing is going to happen. I don't want to do it out here, but if you like plugged in infinity for x, if x equals infinity, then y is going to equal 1. We will eventually talk about when that doesn't happen. I also want to think about a cross, though. Let's think about solving this, because it's going to be a bit much here. Maybe I should find a thinner pink. Right, when y equals 1, we get 1 equals right, 1 is the left side, it's the y value. If I multiply both sides of this by the entire denominator, there is no denominator, and 1 multiplied by it just becomes that, so it's x minus 2 squared, x plus 4 equals x plus 2 squared, x minus 3. This is going to get messy, but I do want us to go through it, because you could always use practice solving this. X minus 2, let's simplify these sides. Squared would be x squared minus 4x plus 4. And x plus 2 squared is x squared plus 4x plus 4. We solve these last things to multiply. Now, we should know how to do this, right? Like, distribute both the x and the plus 4. You can do this in any order you want, but you would get x cubed minus 4x squared, x cubed minus 4x squared plus 4x plus 4x squared plus 4x squared minus 16x plus 16. Let me actually clean that up first, just because I'm running out of space. Let me double check that. X cubed plus 4x, minus 4x squared plus 4x plus 4x squared minus 16x plus 16. I'm going to clean that up just so we have space. X cubed, right, because the minus 4x squared plus 4x will go away. We can combine this like term. Minus 12x plus 16 is going to equal Let's distribute this one now. X cubed. I think Mr. Wangcho made something pretty clever here. Plus 4x squared plus 4x minus 3x squared minus 12x minus 12. So I squished there, but we should be able to see a lot of things going on here. X cubes will go away. Negative 12x plus 16 equals 4x squared minus 3x squared makes x squared plus 4x minus 12x is minus 8x minus 12. I hope I did this right. Alright, do I see where this is going? I feel like he would have made this. Oh, no, wait, maybe. 0 equals x squared. Now it's ZPP solving. Adding 12x to each side. Plus 4x minus 28. But he even made us use a quadratic formula on this. It seems like a lot. That's not factorable. Let me make sure I didn't make a mistake. X squared minus 4x plus 4. Plus 4 plus 4 distribute that. X cubed minus 4x squared plus 4x plus 4x squared minus 16x plus 16. I got rid of those things. I did that all right. X cubed plus 4x squared plus 4x minus 3x squared minus 12x minus 12. Let me see what he had. I'm cheating in his notes. I mean, it looks like I did it right. I just really can't imagine that. Now you get to see deep into the teacher's stuff, so hopefully this is worth it. I really can't imagine him making one that we had to solve with the quadratic formula. Oh, he completed the square. But I guess it is. So apparently it's... You might kill me for not going through this. Negative 2 plus or minus 4 root 2. If we want to fudge this a bit, it's going to be approximately negative 2, right? 4 root 2. Root 2 is like 1.5. 4 times 1.5 would be 6. Negative 2 plus 6 is 4. Negative 2 minus 6 is negative 8. So when we actually graph this horizontal asymptote, we should have a cross at the x values of 4. Well, I kind of just gave away the extra credit problem I thought I would have. And 1, 2, 3, 4, 5, 6, 7, and negative 8. Please ask me questions about that. And of course, we're going to get practice, but we do have to move on because this is getting a lot longer than I had hoped. When x is greater than, care about this point first, 3, we should see we get all positives everywhere. It's going to start over here. Why am I starting it above this? That's because I know it's going to have to cross there, right? So visually, you should see like you can't start under this asymptote. So it's going to have to cross it. Wait, I do that wrong. It's going to have to start over it and hug it. So it's hugging it above, going through the pink, and it's going to cross the green because that comes from x minus 3, which is not squared. This asymptote, this is the key, which is x minus 2 is the binomial that gives it a square. So it's going to stay on this side, which makes sense because it has to go through these 3 points. That could only happen if it started over here. So visually and algebraically it makes sense. And it's going to make even more sense. This is x, comes from x plus 2 up top, which is squared. That means a bounce. It wouldn't make sense for it to go through here because there's no cross in this section of the blue. Over here, this asymptote comes from x plus 4, which is not squared, so it's going to diagonally go up. It's going to go through here, hug it, and on the bottom, go towards there. That's a lot going on. I'm going to leave it up here. Please ask me questions, and we'll do examples. That obviously I think got a lot clunkier than I had hoped, but we're going to roll with it. And feel free to ask me questions. I always appreciate your guys' flexibility. And again, it's good practice just to see some things like we can do a lot of things, even if you don't think they're in the lift. Think about them on your own. Some of the harder algebra that I did.